Today we're going to look at using our skills that we've learned in solving rational equations to solve some real-world problems. Okay, we're going to look at this typical distance problem in terms as a literal equation in which we move the letters around, the variables, in order to solve for a certain letter. So if we want to solve for r, we move the t over and divide by t, and r equals d divided by t. Now we're going to solve d equals rt for t. And again, we're going to do the same thing. We're going to move our r over this time, and t is going to equal d divided by r. Knowing how to do this can really help you whenever you're solving these equations when they do not fit into the typical order that you're used to following. Let's look at a motion problem. So generally speaking, we have our rate times time equals distance, and that's what we're used to using. We're going to look at example 1. Please turn to page 560 in your textbook and read along with me. It says that Troy and Philip decided to spend the day canoeing on a river with a 3-mile-an-hour current. They began paddling the river at 9 a.m. After stopping on an island for 1 hour to eat lunch, they paddled back down the river and arrived back at their starting point at 3 p.m. If they typically paddled at 5 miles per hour in still water, how far up the river did they travel, and when did they stop for lunch? So in this case, we are going to let d be the distance traveled up and down the river, and we're going to look at our upstream value. It says that in still water they traveled 5 miles per hour, so our basic rate is 5, but the stream is flowing at 3 miles per hour. So when they're going upstream, they're going against the current. So we're going to take off 5 off of the rate for that. When they're going downstream, they're going with the current. So we're going to add 3 because it makes them go faster. And we know that the time is going to be calculated by taking d divided by r, because our question is, how far up the river did they travel? So we're trying to find d, and we already have derived that d divided by r is going to give you our t, because we need to find our t first of all. And we can see also that they spent 5 hours paddling. They left at 9 a.m. and got back at 3 p.m. And if we add those together and if we find our d, we're actually going to change the fraction so we can get rid of it, and we have 4d plus d, which is 5d, equals 40. So our distance is going to equal 8 in this case. And knowing that our distance is 8, then we can decide that that is going to be our distance up the river, and our upstream time is going to be 4 hours because we said our distance is 8, so our time is going to be 4, and so they must have stopped at lunch at 1 o'clock. 9 to 1 is 4 hours. And then downstream, again, we said that d divided by 8 was our time, so 8 divided by 8 is 1 hour. Let's look at example 2 now. Go ahead and read along. It's on page 561. When Lisa flies home for Christmas, her flight time is 12.5 hours shorter than the time it would take her to drive the 780 miles. If the plane's average speed is 6 times the average speed of a car, find both speeds. If you look in your book, you can see that this is actually organized as a table, which might be really helpful for some of you. So we're going to let R be the speed of the car, and then we're told that the plane is 6 times that. So the plane is going to be 6R. In both cases, the distance is 780 miles, regardless if it's by air or by land. And we also know that it takes 12.5 hours shorter when she flies than when she drives. So let's think about how that might work. First of all, we need to think about the fact that we decided that distance divided by rate gives us our time, because we don't know the time for the car, or we don't know the time for the plane either. We just know that it's shorter than the car. So we've plugged this in here, and we're going to think of 12.5 hours as 25 over 2. That is an improper fraction, and that's going to help us just in doing our calculations. It's easier to do improper fractions than mixed numbers. So if we look at the fact that 780 over R equals the plane plus, so we're taking the car, which is here, equals the plane plus the 12.5 hours because it said it's 12.5 hours shorter. And when we solve this all out, well, we can see that our least common denominator is 6R. So we have to multiply this equation by 3R. And we have to multiply this equation by 6. And we're going to do that to everything so that everything is in a common denominator. And when we do that, we end up with this equation right here. And when we divide that out, we decide that R is 52 miles per hour. Now, if you'll remember, the R was our car rate. So the car goes 52 miles per hour, and then our plane goes 312 miles per hour. And then if we want to convert that to figure out the time that it takes the car 15 hours and the plane 2.5 hours. Okay, let's recap here for just a moment. Whenever you're solving these problems, it's a good idea to make a table and fill in the information that you know, and then solve for what you're trying to find out. I want you guys to go ahead and make a table for number 1 in your exercises by yourself, and then I want you to do numbers 5 and 11 together in partners. Do not do this full assignment.